Assalamualaikum warahmatullahi wabarakatuh. I am Nur Fatihatur Rawdhah binti Muhammad Ali. The presenter number 77 is going to present on a research titled The Effect of Mechanical Stirring on Microstructure of CNT Reinforced Aluminium Matrix Composite for IRID 2020. So, I will start the presentation with the background of the study on how and what the research is about. The research started with the interest on the matrix material of the composite, which is aluminium metal, the most abundant metal in Earth's crust, making up more than 8% by mass. Aluminium is very much known as the lightest engineering metals, but is not particularly strong by itself, alloying the aluminium with other metals manifold countless advantages. To top the great strength to weight ratio of aluminium alloys, researchers discovered aluminium matrix composite, and this composite, especially the aluminium silicon alloy composites, has escalating demands as shown by the wide applications of the metal matrix composite. Now, the question is how to maintain the good standard of aluminium matrix composite. Surely is to reinforce the matrix with a reinforcing agent that have a superior attributes. Carbon nanotubes have been in the limelight as ideal reinforcing agent as it is ultra strong because of its ultra small size. Enhance the mechanical properties by transferring loads from the metal matrix to CNT, which is called as fine grain strengthening. So the next question, how to fabricate a CNT reinforced aluminium matrix composite that is up to its high standard? CNT tend to agglomerate and the primary A356 ingot have dendritic arm structure, while a lightweight and high performance is desired. Studied from previous researcher, mechanical stirring will solve the above problem. Now, we will move on to the methodology. First step is to premix 0.5 weight percentage of multi-wall carbon nanotubes with 0.5 weight percentage of magnesium. The purpose of magnesium is as wetting agent to bridge the carbon nanotubes to the metal matrix, and both of the material will be encapsulated in aluminium foil. The next step is to have 400 grams of A356 aluminium alloy to be heated up to 700 degrees Celsius before it was brought down to a constant temperature of 650 degrees Celsius. The reason for it to be heated up to 700 degrees Celsius is to ensure that it is fully melted. And the next step is to have the encapsulated premix being put into a plunger and injected into the molten alloy in the crucible before it was mechanically stirred using a mechanical stirrer equipped with a 3-blade impeller for 500 rpm. After 10 minutes, it will be immediately poured into a mold which is being preheated at 150 degrees Celsius. Next is to prepare the sample. After it was being cooled down to room temperature, it will be ground, polished, and etched using color solution for 10 seconds so that it can be observed under the optical microscope. Now let me show you the results. The first picture is the as-received A356 microstructure under OM at magnification of 500 times, while the second picture is the mechanically stirred MWCNT reinforced A356 matrix composite microstructure under OM. Did you see the difference? The first picture is the common alpha aluminium morphology with dendritical arms microstructure, while in the second picture is the non-uniform rosette-like microstructure, proving that the dendritic arms are broken after being subjected to external mechanical force. The third picture is the FISM image of homogeneously dispersed MWCNT in the matrix, proving that the MWCNT does not agglomerate due to the constant medium speed. it can be concluded that the fabrication of the composite is successful. At medium rotation or 500 rpm mechanical stirring during stir casting, the alpha aluminium dendritic microstructure evolved to a rosette-like structure, and MWCNT is homogeneously distributed throughout the A356 aluminium matrix. The findings in this research manifest abundant opportunity of CNT reinforced aluminium matrix composite, as these high performance composites can be achieved after eliminating the two problems in fabrication with a relatively low cost, which is using a mechanical stirring. And that's all from me. Thank you.